I am writing code now for almost 30 years and I'm being paid for that for maybe 20. And only now I was finally able to check out the vertical slice architecture. And let me tell you, it might be developer life changing. Now in this video, I will show you different approaches on how to build a simple .NET Web API. We will cover traditional layers, clean architecture, and finally the vertical slice architecture with CQRS and Mediator. And the best part, you can download the complete source code of all these projects with the link in the video description below. And if you're new to this channel, hi, I'm Patrick God. Yes, God really is my last name. Welcome to all things .NET and Blazor. And now let's dive right in after hitting that like button. All right, now real quick, what we're going to build is this little application here, meaning we have a game character API with some operations, CRUD operations, and a little bit more like create the character, get the character by ID, or level up the character. And we start with the layered approach, traditional controller, service, and repository. As you can see, we got our controllers, or in this example, then one controller. This controller will call a service, this thing will call a repository, and then repository is in essence the data access layer, and there we will get data from a database and return it all the way through to the controller. I think you know that. Let's have a look at the project. There we are already, and as you can see in the Solution Explorer, maybe you know the drill, right? We have here our game character class, pretty simple stuff with an ID, name, class, and a level. And then we have the controller here. The controller, as you can see, in essence injects the game character service, like in the get all method, then calls this service. So let's have a look here. And then here we see the interface with all the methods. And then we go to the implementation. There, again, not a lot of code, similar to the controller, but then in the repository, we go to the implementation, and there then we inject finally the data context. Entity framework is used here with SQL Server Express. And then there's the business logic in the end, right? So here the update method, there we got a bit more lines of code and so on. So this is the traditional approach. I think in particular for beginners, this is pretty easy, pretty simple, and many small applications can totally work with this approach. But the big question now is, why am I telling you all this? Why this transformation? Why first the traditional layer approach, then moving on with clean architecture, and then vertical slice? Well, what I want to show you is the following: coupling and then also cohesion. These are the big words, topic, you name it, in regards to all these architectures. Now first, what is coupling? Coupling is how much different parts of a system rely on each other. We've got tight coupling and loose coupling, and tight coupling means that changing one part can break another, while loose coupling lets parts work independently, making the system easier to modify. So maybe you already know where I'm going with this, but let's first have a look at cohesion as well. Now cohesion means it measures how well elements inside a module fit together. High cohesion means everything in a module serves a clear purpose, making the code easier to understand and maintain, while low cohesion leads to messy, unfocused code. And when you now look again at the traditional approach, right, with services and so on, then maybe coupling is rather tight, right? The controller has to call this specific service, the specific service has to call this repository, and cohesion is rather low, meaning that for one feature, we have to check the controller, then move on to the service, write code there, then in the repository. So we have to change code in a couple of files. Let's see how well this results in the end with comparing all the other approaches as well. But to summarize, coupling is how things depend on each other, and cohesion how well things belong together. So now, next, let's check out the clean architecture approach and decide what about coupling and cohesion there. First, I've got other videos about the clean architecture where I dive deeper than here. I won't go very deep here. And of course, the Clean Architecture Masterclass might be something for you. There we go really deep in the .NET Web Academy. But the only thing you need to know first here, let me pull up the mouse and don't get confused by the count of the slides here. No, we have not 300 slides. It's way less, so please don't stop the video. But the important thing here is we have different layers, right? As you can see here, we have domain, application, presentation, and infrastructure. And as the arrows may already imply, is that these layers point inward, meaning that when we reference projects, because in the end these layers are represented by projects, several projects, different projects in our Visual Studio solution, then here the application project, for instance, can only reference the domain, but the domain cannot reference the application. So it's not going outwards, always inwards. So here in the domain, for instance, we've got our entities. Then in application, we can have services, repositories, stuff like that, or at least interfaces of repositories, because as you will see in a sec in the project, might be the case that the presentation layer has to access something in the infrastructure layer. So that's one exception many teams do, that or allow that the presentation can also go kind of sideways, right, and reference the infrastructure. With that, then of course it also has access to the application layer. And this then means that maybe you see a construct where you get an interface of a service or repository in the application layer, but the actual implementation then is in the infrastructure layer, right? Looks complex at the beginning. And just to show you another image here, domain at the bottom, then the application, then presentation, infrastructure. And as you can see here, the infrastructure usually then accesses the database. But let's have a look at the actual implementations in the project. All right, there we are. And as you can see now, layers are organized in several projects in this complete solution. In the domain, we got again our game character. Then we got the next, which is the application. And what I also did here is I already use commands and queries, but without the mediator pattern. Let's have a look at the slide now. There it is. And as you can see, in essence, this means the following. With every controller, as you've also seen with the service approach, right? We have requests, and the requests now with CQRS stands for commands, query, responsibility, segregation. These requests now are split into commands and queries. As you can see here, we've got a command and we've got a query, and the query are all the get requests. So we cannot change something, we just get data, and the commands are everything else. Everything where we change the database, meaning creating something, updating something, and deleting something. Again, I've got another video about that where we dive deeper together with the mediator pattern as well. And this is just the big difference now. And additionally to the commands and the queries, we've got so-called handlers, a command handler and the query handler. And there you find all the business logic. In the end, then there you would also see data access, other logic, and stuff, right? So just so you know, this is CQRS, what we are using here in this clean architecture example, but not with mediator so far. Mediator comes later at the end of this video, so stay tuned. And so now you see in the application layer, we've got something like a create character command, right? And here now we inject the repository, no service anymore, and the handler in this case is the execute method. And when we now check out the controller in the right tab in the presentation layer this time, of course, then here now we see there we create our commands that we got from the application layer, right? And then always call the execute method and then return whatever we get as a result back. Here you can see this other example, which is also totally possible with clean architecture. By the way, in the clean architecture masterclass in the .NET Web Academy, we will also start with the service approach in a clean architecture, right? So you can totally do that. You don't have to use CQRS with clean architecture. Typically you do that, but you don't have to. And then in the masterclass, we transform the service approach then to CQRS with the mediator and see how beautifully this works out in the end. But just so you know, that's why I added it here. And again, you can download the code with the link in the video description. You can totally also use the repository here, or you go or use the CQRS approach and just create your command, execute it, and then you get your result. All right, that said, then we also have the infrastructure layer here, where again, typically data access stuff is done here, again with entity framework. That's why we see the implementation. And this is what I talked about earlier. You see that you've got the interface of the repository in the application layer, but then the actual implementation, we need it in the infrastructure layer. So here it makes sense. We are referencing the application, but the actual implementation now is in the infrastructure. But the presentation layer then can still use the interface, right? Because of how the references work in a clean architecture. So this is a rather complex approach. You see also it is organized by the types, by the abstractions, commands, DTOs, queries, and so on. Although, I'm repeating myself still in the masterclass, what we also do and what I recommend is, instead of using this approach, you can also already use feature folders, and this is already the direction of vertical slice architecture, where we, instead of saying commands, DDOs, and queries, we have folders like game character. And in the game character folder then, all right, there's a new driver available. In the game character folder, then we see that, or we then there for the use cases, we create other folders, and there we put, for instance, a DTO in there, the commands, and so on. But still, the bigger picture is a clean architecture. Please accept my apologies if this is now too confusing, too much. Clean architecture is rather complex, and it's perfect for bigger applications, really. But if you are a beginner, maybe this is just too much, and this is where vertical slice architecture comes in. So let's move on, because now here what you see is, again, these are all the layers, right? We got them in the first approach and also in the clean architecture approach. We have domain, application, infrastructure, presentation. In the end, you always have such things, no matter what approach you are using. But in a vertical slice approach, it may look like that, meaning that instead of having only these layers and putting all the code in there, and then all the services work with certain repositories, whatever you're going to use, in the vertical slice approach, what you're going to use there is still the same layers, but they are more self-contained, or you can also say you organize your code in features or use cases. So when we now have the use case create a character or level up a character, then you would put everything of these layers here in one folder, maybe even in one single file, and everything you need is in that folder. High cohesion, right? And still low coupling, because you are not dependent of anything in the other slices. Still, of course, you need the entities, and this means you can still share code here. And this is why I draw the domain like that. So we have still the complete domain layer available for every other slice. And if you want to use utility classes, services, whatever, functions, then you can, of course, also still do that if it is necessary in your application. But please just remember, the big point here is that you want to create feature folders, use case folders, and put everything you need for this specific feature in one folder, one file, and are totally independent of all the others. But let's see that in action. All right, and this is how it looks. We have our data folder with the data context, we have the game character, and then come the feature folders. So we have the create character folder with only 2 files. In this case, we have the request. This is in essence the DTO, right? The data transfer object, and then also the endpoint. And in the endpoint now we have all the logic, and it's really not much. We inject the DB context, no repository really necessary. We've got other videos on this channel covering the debate, should you use repositories with entity framework, because entity framework actually already is a repository, right? And in this approach, yeah, you don't really need an extra repository. You just inject the DB context directly, and you have the logic here now in the controller, and this controller is just one endpoint, so I think it's totally fine to do it right there. Still, with CQRS, there is a approach that looks a bit differently. We will have a look in a sec. And again, if you want to learn this by yourself with your own pacing, then you can download every project with the link in the video description. But first, as you can see here now, what about the other ones? Well, looks like that. Pretty similar. We inject the DB context and then have the actual logic in the endpoint. Same thing with get all characters, get one character by ID, or level up a character. And you see now it's only one project, right? So no 4 projects, for instance, or even more like in the clean architecture. And it's pretty small actually, and everything works in the program CS as well. You don't have to register any service, any repository, nothing like that, just the DB context, of course. But still, I want to now show you this approach, vertical slice architecture, together with CQRS and mediator. Now, this would look like that. You have still the controller, right, or the endpoints. You can, of course, also use a minimal API. But then you use commands and queries and the mediator pattern, meaning that we can always use the mediator and send the commands or the queries there, and this thing then knows, okay, in this case I have to use the corresponding command handler or the query handler. So for this command we've got the logic in our handler, for this query we've got the logic here in this query handler. So now let's check out this solution. There we are, even less code. Well, I removed or did not implement 2 use cases here. Deleting and getting all characters is not there, that's true, but still, game character, entity, data context is the same. Program says also almost the same. I added the mediator package by Jimmy Bogart, who also, let's say, invented the vertical slice architecture, at least the name, but also the idea in an NDC talk in 2018. So long ago, but I think now is the time to use it more often. Anyways, Jimmy Bogart, great stuff, mediator package and the vertical slice architecture. But now what you can see here is we are actually only using one single file and put everything there. And stay with me, at first I also was not sure, do I really like this approach? I'm really used to using one file per class, but then I tried it, and actually that's pretty nice. As you can see here, we have a static class. Now, why is that? Well, we don't have to name our commands now, create character command, for instance. We can just use this class and then name everything command and handler. And this works for the other use cases as well. Here we're using a record. So this is then in essence our DTO, our request DTO, right? And this iRequest interface comes with the mediator package. As you can see here, it's a marker interface to represent a request with a response. In our case, this is our command. Game character is a well, we want to create a game character, so this is a command. And so that's why we are now here using a command handler, which is in essence the iRequest handler. And we see with that, the request handler wants something, which is the actual request, in our case, this command here, and then it returns a game character. Now the actual handler does the following. We inject the data context, and then also here's our logic. And then in another class, not in the same as the static class, this is important. Here we have our endpoint, our controller. Again, we can also use a minimal API. And here we just inject the mediator and then can send this command via the mediator, get the result, and that's it. And now for the get character by ID, pretty similar stuff. This is now a query, also using mediator. And here we just in the handle a method find a character with a certain ID. And here this looks pretty much the same. And the last example with level up, also pretty clean in my opinion. And with that now, when you think about our questions regarding the coupling and cohesion, as you can see, we only have one project. Simple, right? We have not a lot of files actually. So this might also be very simple. And everything is really self-contained, right? Just look at the level up character use case. We don't have a service, a repository, I don't know, maybe a DTO for creating a character, stuff like that, where we then have to check out or the code, not really checking out the code, but you know what I mean. Look at the code in several layers, in several projects. We have everything in this single file. So if you want to change a feature, you just check out this file, change stuff, and then commit your changes. Everything's great. So if not two members of your team are currently working on this single file, then you shouldn't have any problems, no merge conflicts, nothing like that. And even if you're working by yourself, it's still the same thing, because you don't have to look for all the files, all the places where maybe you need to change something. And if you change something somewhere, you probably don't destroy something at another place in your whole project, right? And this is really, really interesting, and I will definitely dive deeper into that approach because I really, really start to like it. So now the big question, coupling and cohesion. What's the result? This is the result so far in this video. Again, if you have other opinions about that, other experiences, please tell me that in the comments. Vertical slice is pretty new to me, so I will definitely explore it more. But for now, as you can see, the traditional approach with controller service repos for smaller projects, this is totally fine, but still, coupling is tight, cohesion very low. In a clean architecture, coupling is rather loose, of course, but then regarding cohesion, it depends. You can, of course, make it better with the feature folder approach, but then when you have a look at the vertical slice architecture, coupling is very, very loose, and cohesion is very, very high. Now again, for really big applications, clean architecture maybe still is the better approach. I'm not sure about that because I don't have a lot of experience, in particular with really big projects and a vertical slice architecture. But what I can say for smaller to mid-size, maybe even bigger projects, vertical slice could really be the real deal, really. So I will explore it more. Would be interesting to hear or read your thoughts in the comments. What do you think about all that? Do you want to see more vertical slice architecture stuff on my channel? I'm more than happy to do that. For instance, building complete projects with also Blazor. How would this work then? So very interesting stuff in my opinion. So please tell me what you think. And if you haven't subscribed already, please do that. This would really mean the world to me. Thank you very much. And thank you very much for watching. And I hope I see you next time. Take care.